Hi everyone! Today in this video, we are going to learn what assignment model is and how we can solve the assignment problem. By the way, assignment model is actually a second form or a second special form of a linear programming model that is similar to the transportation model. Now, what is the difference between the assignment model and the transportation model? Or when can we use the assignment model or when can we use the transportation model? Here, the assignment model, we can use this one whenever we only have one unit per source and per destination. That means that um, it is different with the transportation model because in the transportation model we can have limitless number of supply and limitless number of demand. For the assignment model, we are limited to one unit only per supply and per destination. Example, example of assignment model that we can apply or we do in real life is when we assign people to a certain project or a salesperson to a certain territory or city, or we can assign contracts to a particular bidder, or we can assign a certain job to a certain machine, etc., etc. Now, let me give you an example of assignment, a simple assignment problem. So we have here the problem of a taxi company with four taxis and four passengers. So which taxi should collect which passenger in order to minimize costs? So here we have one unit per source and one unit per destination. That means one taxi, one passenger. So the problem right here is that what which taxi should a certain passenger be assigned to in order to minimize the cost? And that is a problem of the taxi company. Another example of an assignment problem is right here. We will call it a fix-it shop case. And by the way, this is a minimization assignment problem. So here, the shop just received three new rush projects to repair. We have one radio, we have a toaster oven, and we have a broken coffee table to repair. Now, the shop has three repair persons, each with different talents and abilities. The owner of the shop estimates what it will cost in wages to assign each of the workers to each of the three projects. So here in this table, we can see that if Adam will work on the radio or will repair the radio, the cost for the labor will be $11. If Adams would repair the oven toaster, then it will cost the owner of the shop $14. For Brown, if Brown would repair the radio, it will be only $8. If Brown will repair the table, it's gonna be $11. So on, so on, and so forth. Now, you might think that no, we don't need any kind of method to be able to solve this because this is very easy. We can just assign the radio to Brown or Adams to table, and then we can assign the oven to Cooper. We can just do that, right? And then we can see if how much in total will cost. Also, we can just list all the possible combinations. This one, in this table, we can see the possible combinations of the three repair person to the three projects. Now, from that combination, we have this total cost right here in the last column. So as you can see, if ever Cooper will be assigned to radio, Brown will be assigned to oven, and Adams will be assigned to the coffee table, then the total labor cost would be $25. And from all the combinations, that is the least, um, that is the minimum cost that the shop um, can spend, or the owner of the shop will be able to spend. So we can just, we can just list all the possible combinations. However, what will happen if we have a lot of projects? We have a lot of repair person. Can we do all the possible combinations manually? Can we do that? Well, if you're willing to do that, then yes, but it will really take time. So with this one, we have this what we call Hungarian solution method that will help us determine the minimum combination in a certain project. First step, by the way, for the Hungarian solution method is we will find the opportunity cost or opportunity table. And then second, we are going to test if this opportunity table is now optimal using the line test. And third, if needed, we are going to revise the opportunity cost table. So let us use the previous problem with regards to the coffee, with regards to the repair person and to the project to do the Hungarian solution method. First, for the opportunity cost, first step would be what we call the row reduction. We are going to subtract the smallest number in each row from all the numbers in that row. Example, so we have here on the first row we have 11, on the second row we had 14, on the third column we have 6, sorry. So in this particular row, Adams, the least number in that row is 6. So that means we are going to deduct all the unit costs with 6 in this particular row. For the second row, we have 8 as the least number or the smallest number in that row. So we are going to subtract all the numbers by 8. And for the last row with Cooper, the least unit is 7. So we are going to subtract 7 from all the unit number in that row. Once you have subtracted all the smallest number, then we will have a new table. We have here 580, 023, and 250. Once we have the new table, we are going to do the second step. That will be the column reduction. And by the way, this is still under opportunity cost. So for column reduction, from the word column itself, we are going to subtract the smallest number in each column from all the numbers in that column. So this is similar with a row reduction. It's just that we are going to focus on the column itself. So for the first column, 1, the least number is 0. So basically, all the numbers in this particular column will remain the same. And for the second column, since sorry, the least number is 2, so we are going to deduct 2 from all the numbers in that column. So that would be 8 minus 2, and that would be 6. 2 minus 2, that would be 0. And 5 minus 2, that would be 3. And for the third column, the least number is 0, so we are going to deduct 0 from all the in that column. So 0 minus 0, that would be 0, still the same thing. So we have here a second table after the column reduction. We're done with step 1. Now we are going to test if this column is optimal already. So we are going to do the line test. Line test is drawing a minimum number of vertical and horizontal straight lines that would cover all the zeros in the table. So we have here how many zeros? 4 zeros. And we need to cover these zeros by drawing a vertical or horizontal straight lines. First, we can cover the second row by drawing a horizontal line. And then third row, vertical line. So that means that we have two lines. We have drawn two lines to be able to cover all the zeros in this table. Now, how do we know if it is optimal or not? So this is not optimal because there are only two lines, and however, there are three columns and three rows. So since it is not equal, then optimality test failed. That means we need to revise this particular table. How do we revise it? So to revise the opportunity table, present opportunity table, we have to, number one, subtract the smallest number not covered by a line from every other uncovered number. Since in the first table right here, the uncovered number is, let's visit the previous table here. The uncovered number is 2. So that means we are going to deduct 2 from all the uncovered numbers. So that would be 5 minus 2, 6 minus 2, 2 minus 2, and 3 minus 2. After that, we are going to add 2 to the intersection of the lines. Since the intersection of the two lines is this one, this 3 right here, then we are going to add 2 right here, just like this table right here. So 5 minus 2, that would be 3. 6 minus 2, that would be 4. 2 minus 2, that would be 0. 3 minus 2, that would be 1. And we have added 2 in the intersection, so 3 plus 2 is 5. So thus we have a new opportunity cost table, and this one we are going to check if this is optimal by doing the line test. So after doing the line test, we were able now to cover all the zeros using 3 lines. Now that we have 3 lines, and that is equal to the number of rows or columns, then optimality tests succeed. That means we can now assign the projects to the certain repair person. Now, how do we do that? So letter A, we are going to start with a row or column with 1 0 cell. Take note, 1 0 cell, and make the assignment. After that, we will eliminate the row and column from that table. So this was the latest opportunity table that we have after revision. First, right here, it says we are going to start with 1 0 cell. So it has to be a row or a column that has 1 0 cell, and then we'll make the assignment. After that, we will eliminate the row and column from that table. So for column 1, we have 2 zeros right here, so we cannot assign. For the column 2, we can certainly do, since we only have 1 0 right here. For column 3, we have 2 zeros, so we won't be able to assign yet in the third column. And the first row, we can definitely assign because we only have 1 0 right here. For the second row, there are 2 zeros, so we cannot assign. For the third row, there are 2 zeros as well, so we cannot assign. Now, since we can assign in row 1, because it has only 1 0, then we can make an assignment that this Adams will be assigned to the third project, which is the coffee table. And we also eliminated the row and the column for this particular cell. So that means we only have these 2 columns and 2 rows remaining. Next is, again, we are going to look for a 1 0 cell in a certain row or column, and then eliminate the rest. So maybe we can start with column 2. So for column 2, we only have 1 0 right here, so we can assign this project to brown. So that means brown will be assigned to the toaster oven. And lastly, since we only have 1 0 left here, so we will be assigning Cooper to the radio. And that means we have Adams to project 3, and that is $6. Brown to project 2, and that is $10. Cooper to project 1, and that is $9. Total labor cost is $25. similar to what we had in the previous table when we had manually list down all the combinations for the project.